In a previous video, we discussed how to find the equation of a line when you were given a slope. We were given the slope of a line, and we were given a point, an xy value, a point that lived on the line. Our strategy was to plug everything we know into the slope-intercept form of the equation and to solve for b, the parameter that we didn't know, the missing parameter. Today, we're not going to know the slope and we're not going to know the y-intercept. What we're going to be given are 2 points. But we know from previous work that if we know 2 points that live on a line, we can calculate the slope. And as we've seen recently, if we know the slope and at least 1 point, we can calculate the y-intercept. Let's look at an example. Find the equation of a line that passes through the points -6, 8 and 8, 8. Put your line in fully reduced point slope form unless it is a vertical or a horizontal line. We need to stop and talk about this, a vertical line, and we need to talk about a horizontal line. And we need to make sure we understand what those would look like, how do we know if we have them, and how do we work with them. I've sketched 2 lines in the Cartesian coordinate plane. The one in orange is not a horizontal line. The one in orange is a vertical line. So let me change that. The orange line is vertical. The green line is horizontal. Let's take a look at a few x values on the vertical line. On the vertical line, I can see that one of my points is when x is 8, and in this case, y is 9. I can see this is a point in which x is 8 again, but now y is 4. And down here, I've got the point where x is still 8 and y is -2. This illustrates the idea that on a vertical line, your x values are always going to be the same. And we cannot write the equation of this line in the form y equals mx plus b because vertical lines have slopes that are undefined. In other words, it has no slope. When I see that all of my x values are the same, the equation of my line is quite simple. I simply write x's are always equal to, in this case, 8. And I'm done. Let's now consider a horizontal line. In this horizontal line, I'll do something similar. Let's track a few points. For example, right here, this is the point where x is -5 and y is -4. This is the point where x is 1 and y is -4. And finally, this is a point in which x is 9 and y is still, you guessed it, -4. When I see that my y values are not changing, I know my line is horizontal. Horizontal lines do have a slope. They have a slope that equals 0. Vertical lines do not have a slope. Horizontal lines have a slope. Their slope equals 0. If I'm sure that my line is horizontal, all I've got to do to write the equation is write y is equal to that value that all the points share, -4. I can write the equation of a horizontal line in the form y equals mx plus b. In this case, because it's horizontal, my slope value is 0 times x plus, in this case, -4. But you can see that this equation just simplifies to y is equal to -4. So now let's consider a line that is not vertical or horizontal. You'll still see the warning, put your answers in fully reduced point slope form unless it is a vertical or horizontal line. I can see that my x values are different. This x value is 4, this one's 8. They're not the same. And I can see that my y values are different, 5 and -1. So I know that this line is not horizontal and it's not vertical. My strategy is to begin by finding the slope. I would like to recommend, when you're finding the slope, to write your points in this stacked form. I will write a -8, comma, -1, and right below it, I'm going to write a 4 and a 5. In order for me to find the slope, I need to consider the y values and the x values, and more specifically, I need to consider how much y changes, and I'm going to divide that by how much x changes. To calculate how much y changes, I'm simply going to take the top y value and subtract the bottom y value. And I'm going to follow that same pattern for the x's. I'm going to take the top x value, -8, and subtract the bottom x value, 4. If I do the subtraction, I can see in my numerator I have -1 minus 5, which is -6, and on my denominator I have -8 minus 4, which is -12. This is a positive fraction because both the numerator and denominator are negative. And in fact, this is equivalent to 1/2. 6 over 12 can be reduced to 1/2. Now, I know one of my two parameters. I know my slope parameter. What I do not know still is my y-intercept parameter. I need to figure out what b is. In order to find that, I'm going to start with an equation of a line written in slope-intercept form. And I'm going to use the y value from one of my points, and it doesn't matter which one, I'm using the second one. If we were to use the top one, I would get the same result. But I'm using the y value from my point, and I'm going to use the x value from that point. And I am also going to replace m with the slope value that I found. When I do those substitution, the only thing I'm going to be left with is my y-intercept parameter, and I'm going to be able to solve for that. So, in place of, whoops, sorry about the seasickness. So, in place of y, I'm going to put the number 5. In place of my slope parameter, I'm going to place 1/2. And in place of x, I'm going to place the value 4 plus b. If I simplify the left-hand side, I see that I have 1/2 times 4, which equals 2 plus b. And on the left-hand side, I still have 5. If I take away 2 from both sides, on the right-hand side, when I subtract 2, I'm going to be left with just a b. And on the left-hand side, 5 minus 2 is 3. So now I know my other parameter. Now I know my y-intercept parameter. And because I know both my y-intercept and my slope parameter, I can write the equation of this line. The equation of the line that goes through these 2 points is y is equal to 1/2 times x plus 3.